Hello everyone, today we'll start chapter 3. So the first section is 3.1, 3D figures. Okay, so definitions first. Polygons. Polygons are closed figures, it's a typo, closed figures composed of any number of straight lines, segments, and there are specific names for polygons depending on the number of sides it has. For example, if I have this, then we know it's a triangle. We can also have uh, squares, rectangles, uh, trapezoid, etc. Right? These are called polygons. And the next one is polyhedrons. Polyhedrons are unions of polygon regions. Okay, and here it says prisms and pyramids are specific kinds of polygons. We'll talk about those later, okay, in later sessions. So, if you have a polygon, then we need to know these three things. An edge. An edge is a line segment where two faces meet. So, for example, this is an edge, this is an edge, this is an edge, and then we have the top four edges, and the bottom will also have four edges. The other two you cannot see. And then we'll have an edge over there in the back as well. Okay, face. Face is the flat or curved surface. So for example, this is a face, and then this is also a face. And if you see the top is a face and the bottom face you cannot really see, and then there's face at the back as well you can't see. And then vertex. Vertex is a point where three or more edges meet. So for example, this point, these points are all vertex. Okay, now here are different types of polyhedrons. Okay, and there are more, of course, but here's just a few examples of polyhedrons. Okay, and you guys can find these on your workbook on page 81. So now you should go over those, but I think you'll be able to go over them and understand and memorize them yourselves. So here we're just gonna go over a few examples. Oh, before that, a net. What is a net? A net is a two-dimensional figure that can be folded on its edges into a three-dimensional figure. Okay, so it's basically a 2D shape, and then after you fold it, it's gonna be a 3D shape. Okay, so if you want to find the net of a 3D figure, then you're basically unfolding the 3D figure to find the net. Now, example number 1, which is not a net for a cube. Okay, when you have a cube, we know that the top, there's only one face on top and one face on the bottom. Okay, so you can, and then there are four faces horizontally. So we know the first one must be a net for a cube because after you fold these four faces, they're gonna enclose a cube with the top and bottom faces. But the second one here, we have two squares on the bottom, which means if you fold it, you're gonna have two faces on the bottom. Is that gonna be true though for a cube? No, there's only one face on the bottom, so this one is not a net for a cube. Okay, what else? Well, this one, four faces in the middle, one face on top and one face in the bottom. That can be folded into a cube. What about this one? This one, again, two faces on top and one face on the bottom. One face on the bottom. The bottom is fine, but two on top will not work. So this one is not a cube either. Okay. All right. Next example, draw a net for the 3D figure. Okay, so for this 3D figure, the hexagon pyramid, we can see that the base is a hexagon. So if I draw that, oops. Well, it's very hard to draw it like that. Well, just assume that it looks like this. Maybe let me just try once again. No, one more time. There. Okay, just assume that it looks like that. And then we can see that these are all triangles. So if we draw triangles on each side of the hexagon, okay. Then after you fold these 6 triangles upward, you will form this hexagonal pyramid. Okay, and then let's look at this rectangular prism. Well, this rectangular prism, it has a base of a rectangle. So I will draw a rectangle first. And then this face and the face at the back are rectangles as well. So that will look like this. And then the two face on the sides are 2 triangles. So look like that, and then that. Okay. Whew. So this is a net for this prism. So if you fold these 2 up, and sorry, these 4 upwards, then that will form this prism. Okay, example number 3. Draw the 3D figure for the net. Well, this is going to be challenging. Okay, so this is a triangle, has a triangular base. Okay, so the base will be a triangle. And then the other 3 faces are triangles as well. So if you draw okay, that looks better. Okay, so we can see that this one is the face over here. Maybe let me use a different color. This one is the face over here. And then this one is the face over here. And of course, the one at the back will be the face over here. Okay? Yeah, all right, last example. Draw the 3D figure for this net. Well, we have a circle on top, a circle on the bottom, and then a rectangle in the middle. What will give you this shape? Well, so we know that this shape has a height of that. And then if you draw the top and the bottom as circles, then this one is just a cylinder. It's just a cylinder because the top, even though it doesn't look like a circle because it's 3D diagram, but if you look from the top, it's gonna be a circle, and the bottom is also a circle. It's a cylinder. Okay. Yeah. So we will go over another section as well. It's 3.2, surface area of a prism. Okay. What is a surface area? Surface area is for 3D objects only. Okay. So surface area is the sum of all the areas of each of the face of an object. Okay. So you're basically adding the area of all the faces of an object, and that will be the surface area. So the formulas you may need for this section is the area of a rectangle and the area of a triangle. Okay? So the area of a rectangle is length times by width, and the area of the triangle is half times by base times by height. Okay, let's see how we will use that. Okay, first example, surface area of a rectangular prism. So find the surface area of this rectangular prism. To find the surface area, we'll need to know how many faces there are, right? Because by definition, surface area is the sum of all the faces, of the areas of all the faces. So why don't we just draw a net for this one? So the base is a rectangle. And then the top is also okay. So this is the base, the face on the bottom, and then this is this face. This is the face at the back that you can't see. And then this is the face on front. This is face at the back, and we're still missing one more face, which is the face of the top face. Okay, so the top face and the bottom face, they have the same dimensions, the same length and the width. Okay, something like that. So from this diagram here, we know the length is 5. Let me just label that 5 cm. And then this side here, this rectangle here has a length of 4, so this one will be 4. And then what is the 2? The 2 is the height of this rectangular prism. And so the 2 will be this side here, 2 cm. So in order to find the surface area, we'll need to find the area of all the faces. But what we've noticed is that this face and this face are exactly the same. This one and this one are exactly the same. This one and this one are exactly the same. So if we can find these 3, then we can multiply all of them by 2 to get the surface area. So let's just do this one together. So we'll do the front. This is front. Front is equal to 5 times 2. 5 cm times 2 cm. That's 10 cm squared. Now remember, because it's surface area, area has a unit of units squared, square units. Okay, so the front, it's 5 times 2. 5 times 2 is the area of the front. And because front and back have the same area, so you multiply that by 2. We'll do that later altogether. Okay, and then we'll do top. Top is equal to, top is this one, which is here. So it's 5 times 4 equals to 20 cm squared. And then we'll do the right side, right face. Right face is this one, which is 4 times by 2, 8 cm squared. Okay, so altogether we have 10 times 2, two faces, one front, one back, plus 20 times 2, so one top and one on the bottom, plus 8 times 2, one on the left and one on the right. So that's 20 plus 40 plus 16, which is 76 cm squared. Okay, now let's do the second example. The second example is a little different. It's a rectangular prism, but with a hole in the middle. Okay, so to find the surface area, we need to find two parts of the surface area. One is the rectangular prism outside, and one is the rectangular in the hole there. Okay, so let's find the rectangular prism. Sorry, let's find the surface area for the large prism, the bigger prism outside. So the front face, this face is a rectangle minus the little rectangle inside. So for the large prism, the front face is the big rectangle minus little rectangle, and the big rectangle has a length of 10 and the width of 5. Okay, so 10 times 5, and the little one here has a length of 4 and width of 2. 2 times 4, so that is equal to 50. Let's write it here. 50 minus 8, which is 42. Okay, so that's the front face. And then we'll do the side face, which is, let's do the right. The right will be length of 8, width of 5, so 8 times 5, that's 40. Let's do cm square, write those down. And then we also have the top face. Oops. The top face, it has a length of 10 and width of 8. So this one is 10 and this one's 8. So 10 times by 8 is 80. Okay. And we know for rectangular prisms, the top and the bottom will be the same, right and left will be the same, front and back will be the same. So it's just all of these times by 2. So 42 times by 2 plus 40 times by 2 plus 80 times by 2. And so that's 84 plus 80 plus 160, which is equal to 324 cm squared. And so that's the large prism. And we also have a small prism that's in the hole there. So let's do it here. And for the small prism, we actually only has 4 faces, top, bottom, left, and right. We don't have the front because the front is hollow, right? The front and the back are uncovered. So let's do the top first. Top and bottom are the same. The top has a width of 4, and the length is the same as the length for the bigger prism. Width is 4, length is the same as this one, 8. So that'll be 4 times 8, 32. And then the right face is this one. This one has a length of 8 and a width of 2. So that will be 2 times 8, 16. Okay, so altogether it's 32 times 2, top and bottom, plus 16 times 2, left and right. So that will be 64 plus 32, and so 96 cm squared. Okay, so for this example here, we have the small prism, 96 cm squared, and the area for the surface area for the larger prism, 324. And so altogether, the surface area will be 96 plus 324, which is 420 cm squared, square centimeters. Okay. All right, last example. This example is the surface area of a triangular prism. So how do I find the area of this prism? First of all, again, we need to know what the net will look like. Okay, so let me just draw that so that you guys can see what the back will look like. So the net then will look like that it has a base of a rectangle. And then this face is also a rectangle. So I'm just gonna draw that. Okay. And then we have this face. It's a right angle triangle. So look like that. And then this side will look like that. Okay. And then this face again is a rectangle. It's a longer rectangle. All right, that's better. Okay, so here is my net. And we'll need to label the dimensions. So this one is 5 centimeters, and where is this? This is the length of this rectangle, 5 cm. And then we know that this is 3, this is right here, or we can say this is 3 cm, sorry, 3.5. And then we also have that the right angle triangle has a base of 3, so this base is 3. And what else? We know this side is 4, so this side is 4, and this side is 4, because these two sides will align with each other, right? So this 2 is 4 centimeters. Okay, now we need to find the areas of each of them. So this one, this one, this one, and then these two are the same, so we can find 1 and then multiply by 2. So front face here, it's a triangle. Triangle has a formula of half times by base times by height. So half times by base of this triangle is 3 centimeters, and the height is here, it's 4. So the base and the height of a triangle is basically the two sides that forms this right angle. Okay, so this one and that one. You multiply these two sides and multiply by a half. That will be the area of one triangle. And so this is equal to 6. Okay, and then we have this one. Let's call it the top face. The top face. The top face is a rectangle, has a length of 5 and width of 3.5. So 5 times 3.5, that's equal to 17.5. Yeah, okay, so these are all centimeters squared. Okay, and then we have this bottom. Bottom face is length 3 with 3.5, so 3 times 3.5, that's 10.5 centimeters squared. And then we also have this one, that's the left side. Left side is, what is it? Length of 4, width of 3.5. So 4 times 3.5. That's 14 centimeters squared. Okay. So now we're just gonna add all the faces, all the areas of all the faces together. Front, because front and back are the same, so we need to multiply the 6 by 2. And then plus the top, 17.5, plus the bottom, 10.5, and then plus the left side, 14. So that's 12 plus 17.5 plus 10.5 plus 14. So altogether it's equal to, let's see what it equals to. So that's 54 centimeters squared. So altogether it's equal to 54 centimeters squared. Okay. So for today, you guys will have 2 homework. One is for 3.2 up here, and the other one is for 3.1 up here. Please try your homeworks and let me know if you have any questions.